Hi, Mr. Richards here. Today's lesson is on solving multi-step inequalities. We're going to solve linear inequalities involving more than one operation and solve linear inequalities involving the distributive property. Our first example, Anna had a budget of $115 for faxes. The fax service she uses charges $25 to activate an account and 8 cents per page to send faxes. How many pages can Anna fax and stay within her budget? Now it's nice, we're given the inequality 25 plus the 8 cents times the number of pages is less than or equal to 115. Let's go ahead and solve that inequality, and we're going to solve this very similar to the way we solve multi-step equations. I'm going to rewrite this just to give myself some room to work. We're looking to isolate our variable p, so we need to move the 25 first by subtracting it from both sides. We're left with the 8 cents per page is less than or equal to 90. And then divide by that 8 cents per page, since the opposite of multiplication is division. In the result, we're dividing by a positive, so we do not need to reverse the inequality, is 1,125. So P is less than or equal to 1,125, which means Anna can send at most 1,125 faxes. What about this inequality? Now we're going to also be asked to graph it on a number line. I'm going to once again rewrite this to give us a little bit more room. We want to isolate the d, so let's subtract the 13 first on both sides. Our result, do not lose track of that negative with the 11. Negative 11d is greater than or equal to 66. Now, when you're subtracting numbers or adding numbers on both sides of an inequality, we never reverse the inequality then. Sometimes a common mistake once we learn that when we divide by a negative on both sides, that we reverse. Sometimes we say, oh look, there's a negative, no, and then we have to reverse. No, you're only doing that when we divide a negative, which is what we actually do next. We divide by the negative 11 on both sides, and we're left with d is less than or equal to, again, we divided by a negative number on both sides, so we reverse the inequality. 66 divided by negative 11 is negative 6. And when we go to graph, a number smaller than negative 6, a number bigger than negative 6. Let's put an open circle at negative 6, and then you can test, is negative 6 less than or equal to negative 6? Yes, it's true. So we shade in our circle. And again, the shortcut for whether or not you shade in your circle of an inequality involves the or equal to. If you see the line underneath the inequality, you can shade in the circle. Now, which direction is this inequality going into? Test. Is negative 7 less than or equal to negative 6? Yes. So you can shade it in that direction. And is negative 5 less than or equal to negative 6? No, so that's why we don't shade it there. Another way to check our solutions is to rewrite our original inequality. And we're saying that negative 7 is true for this inequality, so it needs to be true for the original inequality as well. So you might as well substitute that in to check. And as you go about solving this, 13, the negative 11 times negative 7 is 77. And sure enough, 13 plus 77 is 90. 90 is greater than or equal to 79, so it checks out. So again, if it's true for our answer in our graph, then it also needs to be true for the original inequality when you go to check. And one other thing, we can write this using this notation. As well. And remember, that is called set builder notation. Now in example 2, we're going to define a variable, write an inequality, and solve the problem. Then we'll check our solution. 4 times a number plus 12 is less than the number minus 3. Let's walk ourselves through that. 4 times a number, let's define our number as n. So 4 times our number is 4n plus 12 is less than, so our less than symbol, the number n minus 3. And the only thing we didn't do yet was say, okay, n is going to be the number to define our variable first. So n is the number, so 4 times the number plus 12 is less than the number minus 3. Now let's go about solving. Let's get all our variables onto one side first. We have 4n here and n there. Let's go ahead and subtract the n from both sides first. And remember, that's the same thing as 1n. So it's not like the n is just going to disappear here. There it does. But 4n minus 1n is 3n plus 12 is less than, don't lose track of that negative, 3. Next, subtract 12 from both sides. You're left with 3n on the left is less than negative 15 on the right. Divide by 3 on both sides. And n is less than negative 5. Now to check the solution, we're saying n is less than negative 5. Pick a number for n that is less than negative 5. Let's go with negative 10. So negative 10 is less than negative 5. Let's rewrite our original inequality. 4n plus 12 is less than n minus 3. We're going to put the negative 10 in for our n's. So 4 times negative 10 plus 12 must be less than negative 10 minus 3. 4 times negative 10 is negative 40, plus 12 is less than negative 13, and negative 40 plus 12 is negative 28, and negative 28 is less than negative 13, so it checks out. So to check an inequality, pick a number that's true for your solution, put it back into the original inequality, and make sure that it is true. You could pick any number. You could have picked negative 6, negative 7, negative 100, anything that is less than negative 5. And one other note on this example, just to get the notation correct here, another way to write this solution is to say, okay, for my set of n's, n is less than negative 5. Just another way to write our solution. Let's continue on. Now our inequalities become a lot of fun where we have distributive property. Let's simplify our left side here first before we continue on. Let's distribute. So we're left with 6c plus 3 times 2 is 6. 3 times the negative c is negative 3c is greater than or equal to negative 2c plus 1. Now, before we add or subtract anything from the left side to the right side or the right side to the left side, let's make sure our side is simplified. It's not. We have a 6c and a minus 3c. So combine those terms before we do anything else. 6c minus 3c is 3c. Plus 6 is less than or equal to negative 2c plus 1. I'm sorry, not less than or equal to, greater than or equal to. Next, let's add the 2c to both sides. And that'll cancel out. And we're left with 5c plus 6 is greater than or equal to 1. Subtract the 6 from both sides. 5c is greater than or equal to negative 5. Divide by 5. And again, we're dividing by a positive 5, so there's no need to reverse. C is greater than or equal to negative 1. And using our set builder notation, solution here, the brace C, and C is greater than or equal to negative 1. Now, in order to graph the solution on a number line, we have negative 1, a number bigger is 0, another number smaller is negative 2. Let's put an open circle at negative 1, but we'll shade it in since we have the or equal to, and test, is 0 greater than or equal to negative 1? Yeah. 0 is greater than or equal to negative 1. Is negative 2 greater than or equal to negative 1? No. And this direction does not indicate to check, but if you were to check it, rewrite your original equation, 6c, original inequality, plus 3 times 2 minus c is greater than or equal to negative 2c plus 1. Now, this will be a huge piece of advice. 0 is true for this inequality. 0 is supposed to be true. So when you go to check it, whenever you have 0 being true, use that number, because look what happens. You'll have 6 times 0 plus 3 times 2 minus 0 is greater than or equal to negative 2 times 0 plus 1. Now as you sort through this, 6 times 0 is just 0, plus the 3 times 2 minus 0, well that's just 3 times 2, needs to be greater than or equal to, the negative 2 times 0 is 0, and then you have 1. It takes a very complicated check if you were to put in something other than 0, and makes it pretty simple, because now we have 6 is greater than or equal to 1, and that is true, so our solution works. Now, what if we solve this inequality and check our solution? Well, let's go ahead and distribute. Our negative 7 times k is negative 7k minus 28 plus 11k is greater than or equal to 8k. Now we're distributing the negative 2 times 2k, so that's minus 4k. And the negative 2 times the positive 1 is a minus 2. And again, before we add or subtract something from the left side to the right side, let's work on combining like terms. We have a negative 7k with an 11k, and 11 minus 7, or negative 7 plus 11, either way you want to look at it, is a 4k minus the 28 is greater than or equal to, and again, on the right side, we have an 8k minus 4k. That once again is 4k. And then minus 2. Now something special happens here as we go to simplify. Let's subtract 4k from both sides to get our variables onto one side. And as you're doing this, you're going, wait a minute. That cancels, I'm left with negative 28 is greater than or equal to negative 2. Well, that's fine, except that negative 28 is not greater than or equal to negative 2. So this is a false statement. And since I have a false statement here, my solution set, well, my solution set is the empty set. And the symbol we have for empty set, kind of like an ovalish thing with a line through it. And that's the solution. It's the empty set. And with the empty set, there is no need to check our solution. You certainly could. You could put any number in, but you'll get false every time. What about this inequality? Well, let's distribute and simplify. 2 times 4/8 is 8r. 2 times 3 is 6. Is less than or equal to 22 plus 8r minus 16. Let's simplify things first. Let's get the 22 minus 16 simplified. So we're left with 8r plus 6 still on the left is less than or equal to 8r, and 22 minus 16 is 6. And notice something here. You have the same inequality. 8r plus 6 is less than or equal to 8r plus 6. And when you go to subtract the 8r from both sides, they again cancel out. And you're just left with 6 is less than or equal to 6. And the thing that saves us here is the or equal to, because 6 is less than or equal to 6. So this is basically all values for r make the inequality true. No matter what you put in for r, you're going to get a true inequality. So our answer is actually all real numbers. And the way we could write this using our set builder notation, put your brace, put your r, since that's our variable, and basically, as long as r is a real number, your inequality is true. Now, if you wanted to check this, and it's sometimes useful to check, we have 2 times 4r plus 3 is less than or equal to 22 plus 8 times r minus 2. Put in any number. And again, if any real number is true, let's just use 0. 2 times 4 times 0 plus 3 is less than or equal to 22 plus r, or 8 times 0 minus 2. 4 times 0 is 0 plus 3, so we have 2 times 3 is less than or equal to 22 plus 8 times negative 2. We have 6 is less than or equal to 22 plus negative 16. And again, we have 6 is less than or equal to 6. Kind of fluky here, but that is true, so our inequality is true. You could put in 1, 2, 3, 100, 1,000,000, and you'll still get a true statement in your check step. That's it for this lesson. Good luck.